So let's take a look at a summary of the formulas that we've seen. So given something of the form y equals a times sine of bx minus c plus d, or y equals a times cosine of bx minus c plus d, the amplitude of the transform function is going to be simply the absolute value of a. The period is going to be the absolute value of the normal period, 2 pi divided by b. And the phase shift we just saw is equal to c divided by b. If the phase shift is positive, it indicates that we're shifting to the left. If the phase shift is negative, it indicates that we're shifting to the right. So let's look at an example. Let's try to determine the amplitude, period, and phase shift of y equals 4 sine of 5x plus pi plus 2. So it helps, I guess, let's first think about the values of a, b, c, and d. So the value for a is the number in front multiplied by the entire function, and so that's going to be 4. The value for b is the value inside here, it's 5. The value for c is a little bit tricky because our general form is bx minus c, and so when there's a plus sign inside, I want to think of that as negative minus pi. And so the value for c is actually negative pi, and the value for d is 2. So in terms of determining amplitude, period, and phase shift, the value for d is not going to be needed because that simply is a vertical shift of the graph up and down. It doesn't change these characteristics, amplitude, period, or phase shift. Amplitude is going to come from the absolute value of a, which in this case is simply the absolute value of 4, which is just 4. The period depends on the value of b, the normal period 2 pi divided by b, so we end up with 2 pi divided by 5. And the phase shift depends on both c and b, and so I have negative pi over 5 as the phase shift. So let's take a look at a graph of this in our calculator and see how the amplitude, period, and phase shift are reflected in that graph. So I want to graph 4 times sine of 5x plus pi plus 2, and the standard trig window does kind of an okay job, but it misses a little bit the top because I have an amplitude of 4 and I'm shifting up 2 units, so the highest point is actually going to happen at 6. So let me adjust the window a little bit here. In fact, let me just look at the graph from 0 to 2 pi. And let me look here from maybe 4 to 8. And I'll change the scale so we count by 2. Taking a look at the graph of the function, we see that the maximum is at positive 6 and the minimum is at negative 2. And the vertical center is at positive 2 because of the vertical shift, because d equals positive 2. That's where that kind of comes into the picture. But it doesn't affect the amplitude because we still get a difference of 8 between the highest and lowest points, and so the amplitude is still 4. The period is 2 pi over 5, and so essentially what that means is that we go through 5 cycles in the time that we would normally go through 1 cycle. So the graph here we see is from 0 to 2 pi, and we see that we go through 5 cycles in that amount of time. The phase shift means that we don't start at the normal sine cycle. We don't start, normally at 0. The graph would be 0, but we're kind of shifted a little bit to the right. Actually, is kind of technically what's happening. We're shifted to the right by pi over 5 units. So let me end with a question, a similar kind of question for you to think about. I encourage you to take a few minutes to determine the amplitude, period, and phase shift of y equals 10 cosine of 1/3 x minus 1. I hope you enjoyed the video. Thanks for watching.